are inclined. That is why you have all these seasonal variations. Okay. So that's why you have this Uttarayana, Dakshinayana also. So the sun is moving in this plane around you as seen by the earth. So it is not moving along the terrestrial equator plane. The inclination is around 23.5 degrees. And for you to have just a feeling, so what we call as Uttarayana is this, the motion from the southernmost point to the northernmost point. Assume this is the earth, the up is the north pole, and this is what we call as Uttarayana and Dakshinayana, the other side. And I'll very quickly tell you, so this Panchanga, Pancha means 5, Anga means part, okay. So it essentially lists these 5 important things. It will list various other things also. So for you to have this picture of how this Tithi comes into picture, you just imagine that you are there, you are sitting here, and the moon is moving around you, and the sun is moving around you. Now, when the sun and the moon are in the same direction, you will not be able to see the moon. Okay, this is what you call as Amavasya. Yam1 refers to Amavasya. You see the dark portion of the moon. Always half of the moon is lit by the sun, but you see this dark portion, and therefore you call it as Amavasya. But then moon hardly takes, see, 23.33 days to go around the earth once. In fact, I distinctly remember, so before I joined IIT, so I joined, so somebody invited, I just joined. Then as soon as I joined, I offered a course. That course I titled as Calendrical Calculations. The first class I went. So somebody warned me, so the students will initially try to see whether you know the answer or not. They will ask you some tricky questions. They said, okay, to make a judgment. They were bright in those days. Anyway, so that's that fellow, I was offering the course, I asked him, do you know why there are 27 stars? Okay, you used only 27, no? Why 27? There are so many. You could have called 30, you could have had 50, you could have had 15. What made you call 27? So this is the question that I asked. Then that fellow asked me, sir, why 12 months in a year? So that's the question that he asked. So before that fellow makes a judgment of me, so I just thought for a moment and then I gave an answer. He was very happy and convinced. So then I explained why 27. So both were done. So and then that talk, fellow's name is some Surya Narayana, something I remember. It was a very bright fellow in the class. So these are based on a physical phenomenon that is happening. Why 27? Any guess? So it has to do with the period which the moon takes. You see? So moon just takes around 27.32 days to complete one orbit around the earth. So therefore you would like to have, see, a period. So the moon spends roughly 1 day in one segment. That segment you would like to, so since it is close to 27, so we have 27 nakshatras. That is the basis. Okay? No, not Purnima.
No.
See, this is something which you have to understand. These are two different things. Forget about sun now. Just imagine Earth-Moon system.
The reference.
So moon keeps moving around you. So you see the moon close to a star, and then so Earth keeps spinning. So the moon comes back to the same star. Okay, this is what is called orbital period. Okay, so this period is 27.32. So now, in the meanwhile, the Earth would have rotated 27 times. So 27.32 days means it is basically the rotation of the Earth. So since it is 27, in one rotation of the Earth, moon covers a certain space. Okay. So angle in the space. So that instead of having 27.3, which is complicated, you will just say 27. Okay, that gives the basis for 27 stars. Okay, why we call. Now this is a different phenomenon. See, you just now understand this. So sun is also moving around you. How long does it take? 365 point something. Okay. So 365.25 and so on. Now the sun and the moon are in the same line. So then he has an Amavasya. So this fellow takes 365, which means he moves roughly 1 degree per day. By the time moon comes here after 27 days, sun will not be there. Okay, this fellow would have moved almost 27 degrees. So moon has to catch. Okay, so by this itself you can say the moon's meeting with the sun will take more number of days, right? So roughly 2 more days on an average. It can be much more. Okay, so therefore the average time interval between 2 Amavasyas will be 29.54. But it can be much more also. Now it is for this reason you have 30 tithis. You understand? Why you have tithi as 30? It is simple. It has to do with this. So it is 27.54. Okay, you put to the other side and you have some 30 tithis. Okay, and how will you now see? Now, if you just imagine the moon leads the sun by 360 degrees within this period. See, sun has moved theta, moon has moved 360 plus theta, right? So therefore the lead is 360. You divide 360 into 30 parts. So the time taken by the moon to lead the sun by 12 degrees is what you call as tithi. Okay? So that is what precisely tithi is. So it is not so easy to compute. So the duration, etc., as you know, that rates of motion are varying. So that is another kind of a problem. So they are all interesting things. So I don't think anybody in the other civilizations, okay, had all this theoretical model. So they have seen this, but then they didn't have this way of reckoning. Okay. So then Panchanga also has something called Vara, Nakshatra and so on. So this is a table which gives you the data which has been presented by Aryabhata. See, in 499 AD, he has written a text called Aryabhatiya. So there is the large period that is taken as the fixed period, 43,20,000 years. In 43,20,000 years, Aryabhata will say moon makes this number of revolutions. See, 5,77,53,336. What will this amount to? This amounts to saying that the moon's period is, see, if you just divide, okay, so you will get something. So this is the period and so on and so forth. This is given for every planet. So it is here which people keep playing around. You understand? So see, somebody will say it is 336. So based on more refined observation, if you change 336 to 320, then this will change here in the 4th decimal. So that is how they keep refining the parameters. Okay. And yes, somebody wanted to ask? Yes, please.
What is it, Sigrocha?
Sigrocha. So that is a little technical. So you can just take it as Mercury. Okay, and that's all I will say for the moment. So they introduced something called Sigrocha, Mandocha. Okay, this has to do with the, see, after all, we are sitting on the earth, whereas these objects are moving around the sun. Okay, yeah. So what you will get is initially heliocentric position. That heliocentric position has to be transformed to geocentric position. So there they will introduce this notion of Sigrocha. And in order to take care of the eccentricity of the orbit, they introduce a term called Mandocha. So there are different levels of computation that has to be done in order to get the. So initially, so it was not very clearly understood by people whether the Mercury is moving around the sun or the earth, etc. Because you just don't know. So you see the object for a short while.
So this will be applicable only for your only for Mercury, Venus, it will not be applicable for Mars, Jupiter, Saturn, because they also have.
I'll tell you, good, that's a good question. There is a distinction between the two. So though all of them will be seen to be some point objects which are moving around in the background of the star, but then as the Mars or Jupiter moves around the Sun, it also moves around the Earth. Right? So there is a distinction has to be made between the two. So as the Sun moves around the Earth, it also carries Mercury around the Earth. So the period with which the Mercury moves around the Earth will be this, on an average, will be the same period as that of the Sun. You understand? So this on the case, so this is one exterior and interior planets. This division was there. So initially they have been calling this as Shigrocha. One can also understand this as, see, if you just associate a period to Mercury, you can associate the period around the Sun, you can also associate the period around the Earth. So in a large period of time, so the average time taken by the Mercury to go around the Earth will be same as the Sun.
Right.
Now you have to associate another period. That period, see, is only 88 days. Therefore, they call it as Shigrocha. Okay, so there is a technical term. So we'll just keep it at that now. Okay, good. Now there is an interesting observation which has been made by one of the commentators called Neelakantha. So in his commentary, this Aryabhatiya is